Yo! Hello, let me turn on the stream on Twitch. Okay. Lights. And camera. And action. And phase in. Woo! Okay. Here we are. Welcome. Today is day 28. Optical flow and stereoscopic nodes. It almost rhymes. Let me open Twitch. Hop in here so I can see the chat. Oh, sweet. I got a new... We're at 11 followers. I got to update the manage goals. Next goal after 10. Let's do... let's do... Oh, I can copy this into the announcement thing, right? I gotta set this up so that these things pop up when they happen on Twitch. That might be an off-stream thing to do. Hey, Michael! What's up? Michael, how's it going? I'm doing all right. I took a peek. This is actually a kind of interesting This is a pretty interesting chapter. A lot of words. I don't know if we're going to get through it today. I don't know if we're going to complete it in one day unless we read a lot real fast. But yeah, it looks kind of looks like a cool section. All right, we're good to go. Yeah, me too. Well, of course, but hoping that you're here too as well. I hope I'm here as well when we finish. That's why it might need to be tomorrow, because by the end of these streams, sometimes I'm just like, you know, like yesterday. I was exhausted at the end of last stream. Out of focus? It's on autofocus. Fries my brain. But let's see, this is stereoscopic, and hey, STEM gamers, welcome back, man. And optical flow, that's right. Optical flow. What's up, what's up? Just getting started with the final chapter. It's the final chapter. Here we go, hop into here. Before we take a look at the book, I want to see if there's tools in here for stereoscopic. What would that be? Transform, tracking, stereo. Stereo? Yeah. I took a peek right before I went live, and it looks like stereoscopic is, there's two things happening. There's stereoscopic and there's optical flow. So they're kind of different. But let's take a look at the book. Let's start it off. This chapter covers the numerous stereoscopic and optical flow-based nodes available in Fusion, and their related workflows. We've got the overview, working with auxiliary deep channels, optical flow workflows, stereoscopic workflows, separate versus stack, setting up stereo in the node editor, disparity channel, and vector channels, and best practices. And for this first part, I'm probably just going to read through this, when they talk about the 3D, setting it up for 3D. And then I want to test some of this stuff, the optical flow, the time speed. I want to do examples of those. So let's check it out. So the overview. Fusion includes 3D stereoscopic and optical flow-based nodes, which can work together or independently of each other to create, repair, and enhance 3D stereoscopic shots. All stereoscopic features are fully integrated into Fusion's 3D environment. Stereoscopic images can be created using a single camera, which supports eye separation and convergence distances, and a renderer 3D for the virtual left and right eyes. So that's why I'm reading through this. I don't really think we can do examples, but it's worth like theorizing about, because I believe this is relevant for like VR goggles, right? I believe. And so, yeah, just theorizing about this stuff at this point, but I'd like to get into VR, so worth just overview. It is also possible to combine two different cameras for a stereo rig. That's how they do, I believe that's how they do 3D films. They record with two different lenses, two cameras, so you can combine them. And then stereoscopic nodes can be used to solve 3D stereoscopic shooting issues like 3D rig misalignment, image mirror polarization differences, camera timing sync issues, color alignment, convergence, and eye separation issues. Hopefully BD stops by, because I think he has experience with this. Quite a lot, actually. Color alignment, convergence, and eye separation issues. The stereo nodes can also be used for creating depth maps. So optical flow overview. So that's stereoscopic, which is over here, stereo. And then the thing I was saying was kind of different, is if we go through optical flow analyzes the motion in a clip and then generates motion vectors between neighboring frames. It generates X and Y vectors from the previous frame to the current frame and to the next frame in sequence, called forward vectors. Once calculated, optical flow data can be used by other nodes to create smooth, slow motion and variable retiming of clips, repair missing frames, and even correct disparity in stereo 3D clips. Note that the stereoscopic nodes, okay, so that's optical flow, and then stereoscopic nodes in Fusion, in the Fusion page, work independently of the stereoscopic tools in the other Davinci Resolve pages. Honestly, it's kind of confusing to say this as an overview right into this, for me at least. But yeah, I guess separating these, they're kind of, maybe we'll find out why they're putting them together in the chapter like this, but I feel like they're kind of different concepts to keep in mind. So the toolset overview. Here is an overview of the available nodes. Optical flow, which is like doing the smooth slow motion from regular footage. You can do optical flow, which analyzes motion between neighboring frames in a sequence to generate motion vectors, which can then be used by other nodes for retiming, motion blur, and other effects. There's the time speed, I want to play with all these. Time speed, retimes a clip at a constant speed using flow interpolation mode. There's the time stretcher, retimes a clip at various speeds using flow interpolation mode. Actually, if you want to look for a clip, maybe it'd be better if you just like say like let's use this clip, because for time speeds, time stretching, I mean we can mess around with some footage that's like we could mess around with GIFs, try to generate more in between frames. There's time stretcher, which retimes a clip at variable speeds using flow interpolation mode. There's repair frame, which generates a new frame using the motion vectors between two neighboring frames. Then there's smooth motion, which smooths the color and aux channels using motion vectors. Tween interpolates between the non-sequential images to generate a new frame. Oh, to like go from one image to another. And then there's copy auxiliary, which includes motion so you can kind of like copy the results and combine them in interesting ways, I guess. Copies auxiliary channels, including motion vectors, into RGBA more efficiently than channel booleans. Okay. All right. There are stereoscopic nodes as well, which again, that's kind of for like the eye alignment stuff and the 3D VR stuff. There's the anaglyph, which combines stereo images to create a single anaglyph image. There's combiner, disparity to Z, converts global align, shifts each stereo eye manually to do basic alignment of images, of the two images together. New eye replaces left and or right. Splitter separates a stacked stereo image into the left and right. Okay, so if you want to make 3D footage, use splitter. Stereo align adjusts vertical alignment, convergence, and eye separation. More alignment. It's a lot of alignment stuff, isn't it? And then Z to disparity converts the Z to disparity, and disparity generates disparity. So again, kind of let's keep moving here. Working with aux deep channels. So working with auxiliary deep channels, certain image formats can contain channels other than RGBA color called aux deep channels. Stereo disparity and optical flow deal directly with auxiliary deep channels. Again, the auxiliary deep channels are like Z depth. There's coverage, the percentage of the pixel covered by the frontmost pixel. Then there's object ID. Let's skim the words here, because we're not going to be playing around with auxiliary deep channels today. But there's material ID, texture coordinates, normal vectors, background color, vector, back vector, world position, disparity. Some extra channels are used by specific fusion nodes. For example, merge, image processing nodes have options on their common controls tab to limit their processing by material ID. And that's a thing, is you can specify the object ID or the material ID so that certain things are only affecting certain objects or groups of objects. There's fog and depth blur, which uses the Z depth. Texture, shader, moving on. Optical flow workflows. The optical flow analysis is a non-real-time process, and depending on your computer, the clip's resolution and the duration of the clip, it can take some time. Optical flow can be computer processing heavy. Oh, speaking of computer processing heavy, I just wanted to point out, yesterday somebody mentioned or suggested using saver nodes. We had them. They were getting saved. That is the workflow to save computer processing. So it was working. We're a little impatient. It was gonna take like 10 minutes and my stream was like breaking, so decided to cancel it, but it was working. So saver nodes are cool. But back to optical flow workflows. The clip's resolution and the duration of the clip, it can take some time to do optical flow analysis. Because of this, the general idea is that you pre-generate the motion vectors either by performing the analysis overnight or using a render farm. Oh, really? Optical flow, really? Really? Either by performing the analysis overnight or using a render farm and save results into an OpenEXR sequence. The optical flow toolset is designed around 4 types of nodes that either generate, destroy, pass through, or construct motion vectors. Huh. So this is, okay, let's find out. Optical flow. The optical flow node generates the vector and back vector data. Typically the optimal performance. For optical performance, you connect the optical flow output to a saver node to save the image as OpenEXR files with the motion vectors stored in an aux channel. Let's try this. Let's get some footage in here. Oh, okay. All right. I know what. We want this. We want Hellcat. This is, of course. Actually, this is honestly good footage to play with because it's so small. It won't blow up the computer. But if we do this, optical flow, add that, and we're hooking it up to a... This should work, actually. Let's not render it out yet. So, oh, so for optical flow, this is supposed to create smoothness. So let's just literally ramp everything up and see what happens. Doesn't look like anything's happening. Okay. Without. With. I don't see anything. I don't see any difference. Don't know what's happening, but I'm excited as well. Classic. Let's just try classic mode. Just turn everything all the way up. I think it's kind of preloading. Oh, okay. Wait. Let's go back to advanced. Everything is amped all the way up, but let's do the pre-render. And then it goes once through and it's pre-rendered. Okay. Now we play it. I don't see anything. I don't see anything myself. I don't see any difference. But there you have it. Success. It generates the vector and back vector data. Okay, maybe there's more that we have to do. Maybe that's probably like the turn on node, right? Now we have to add something. We have to decide what to do with that. Something happened. Let's keep moving. Typically for optical performance, you connect the optical flow output to a saver to save the image as OpenEXR files with the motion vectors. I got it. That's right, what I just said. So the thing is turned on, right? And if we export it as EXR, it would have the data that we just kind of made. But we haven't told it to do anything yet. And we didn't export it. So moving on, we get to choose what to do with it. Time speed, time stretcher. You can create smooth, constant, or variable slow motion effects using the time speed or time stretcher nodes. When optical flow motion vectors are available in the aux channel of an image, enabling flow mode in the time speed or time stretcher interpolation settings will take advantage of the vector and back vector channels. For the flow mode to work, there must be either an upstream, that's what I was just saying. For the flow mode to work, there must be either an upstream optical flow node generating the hidden channels, that's what I was saying, or an open EXR loader bringing these channels in. Yep. And right now we just have a upstream optical flow node. These nodes use this is similar with the yesterday's particle thing, where it's like you had to make the particles and then you attach the geometry to the dots, to the motion of the dots that you generated. Similar here, you generate the stuff and then you choose what to do with it. These nodes use the vector/back vector data to do interpolation on the motion channel and then destroy the data on output since the input vector back vector channels are invalid. Oh, maybe that's why it's hard on the computer, because it uses the vector data and then it blows up the data. Uh-oh. Am I still live? Ruh-roh. You see the error message? Ruh-roh. Okay. All right, seems okay. Scary message, but hopefully it's all good. Keep moving. So that's time speed and time stretcher. And then there's smooth motion, can be used to smooth the vector. Can be used to smooth the vector and back vector channels or smooth the disparity in a stereo 3D clip. Maybe that's why. There is some overlap here. This node passes through, modifies, or generates new aux channels but does not destroy them. So we probably want to try smooth motion, right? Smooth motion. Oh, and then we turn on vector and back vector? Huh? Doesn't look smooth motion to me. Let's see, in effects we got stereo, we got optical flow. Huh? Time speed, where's time speed? Flow? No. Deep pixel, no. I'd like to find it over here first. Composite, creator. Flow generator? No. Okay. What's the thing we're looking for? Time speed. Let's just do time speed. Time speed. Change it to flow. Slow it down. Oh, see, this is working. That's working. Do you see it? That looks good. That looks good. Do you notice like what's happening? Looks good. Good idea. Let me see. Actually, I can do it like this. I can copy this. So this will change the speed, but it won't have the optical flow. That's right. Isn't that? No. Nearest. There you go. How we get these to be the same? Yeah. That's cool. And let me see if I set it to if I set this one to flow, I think it shouldn't work, and that's what we saw, right? Yeah, it just doesn't work because we need to add optical flow first. And then there's nearest, which is just a different normal style of blending, of slow motion, of like, it is blending, right? It's nearest neighbor. I forget like the actual, but these are just like doing, what are the differences here? I want to see the, actually here, let's do one more. Let's just copy this, put it here, and take a look. So now, well, this one is blend, and this one is nearest. So blend definitely looks better than nearest. I think nearest isn't even doing any anything. It's just snapping to the nearest frame. So like I guess, not sure about that. But this is nearest, this is blend, and then I'm gonna move blend over here. They're both blend, and then I'm gonna put optical flow here. Yeah, look at that. Look how much better optical flow looks. And I think if we wanted to, we could go in here and mess around with this. Can we make it more than, can we make it 200? That's cool. And at this point, okay, I got an idea. What if we send this to a saver? Save it to the desktop. I already have a folder called HuhCat. I'll save it into there. In a new slow-mo folder. Slow-mo. And then we go to Fusion, render all savers. That's complete. And then we do a loader. This is gonna be fun. I think this is gonna be awesome. Loader. And we load up. Oh, but that's interesting. It's not, I expected more frames to be made. So this is No, okay, so it did so each frame is like taken from what our optical flow looks like. Right? Yeah, and there's something happening here, which is kind of a mistake by me, which is that I didn't change the length of this clip, but I changed the speed down to 0.27. So we're actually losing like 2/3 of the clip. Something to keep in mind. But let's see. No, let me fix that. What do I have to do? What do I have to do to get? I need to make this timeline a little longer. That's it. It keeps going. Keeps going. Yes. Oh, that's like the perfect amount of time. That was perfect. So we can re-export that. Slow-mo 2. We might have lost a frame or two, but let's export that. Or no, we go up to Fusion, render all savers. So now we do have more frames. Or get this one. Loader, slow-mo 2. Yeah, we got a whole bunch of frames now. And we're gonna do this whole thing again. We do this into an optical flow. Wait, what am I doing? Optical flow. And then a time speed. Oh, we're gonna make this footage look so nice. So we're looking at it up here. The optical flow, we need to change the settings to just the max. We get to do this because it's a GIF. But if this was like just 1080p footage, it probably... I mean, maybe that's why my stream blew up. Or like, hiccuped before. Possible. And now we just speed this back up by 3. We could do math to figure out what the actual... whatever. Oh, and then we can pre-render it. It's not real time, it's pre-rendering. There we go. So it's a little faster than before, which we probably want to fix. We're going to use this. And then play, right? Why didn't that... Wait, I thought I pre-rendered it. And then we have our footage back. I don't know. I don't know what I was expecting. Our footage is just, it's like objectively better now though. If we go to our original here. This is cutting edge technology right here. Welcome to the cutting edge technology. Higher resolution. Next up, we can remove the for VFX. So there's the time speed, that was time speed, and time stretcher. There's smooth motion, which can be used with the optical flow node for stereo. That was interesting. Yeah, I don't know. I don't know what I was expecting. I was expecting, well, what if we make it fast now? Make this, and it's just going to be super smooth, and it's going to look so crispy clean. Cutting edge. Huh? Look at the resolution. We've got repair frame, tween. The tween and repair frame nodes are different from standard optical flow nodes because they have the optical flow analysis and motion vector generation built in. So this might help with what we're doing. Tween will compare two frames and create an in-between frame, which is good for recreating a missing or flawed frame. Repair frame will look at frames on either side of the current frame and repair scratches, dust marks, and so on. Oh, it's like fixing old footage? Because these nodes work with flow values between non-sequential frames, they cannot use the optical flow stored in the images in the input images vector backvector channels, but rather that must generate the flow of each frame, do the processing, and then destroy the flow channels. This being the case, these nodes are computationally expensive. So repair and tween. I think tween is with our original footage here. We just throw a tween node on there. It's red. I think it's BD. Hello. Welcome. We're getting high quality Hawkcat. We're reading about optical flow and stereoscopic editing. I was hoping you'd stop by. So when we get to the stereoscopic stuff, I have some questions. Because you must be familiar with this, the stereoscopic stuff. I'm guessing this is like how you would kind of put together VR footage. Dude, if you didn't sleep, if you only slept 1 hour, then it's basically just one long day. You're basically in one long day if you don't sleep. Did you sleep? Did you get like a couple hours in there? No time to sleep. Ugh. No sleep for the wicked. Amazing. Amazing. I don't understand it. I don't understand how you do that. I commend you, but I don't envy you for no sleep. I envy that you can get 1 hour of sleep and keep going. Just physically could not do that. But advanced optical flow processing. The optical flow, repair frame, and tween nodes include a faster GPU-based optical flow algorithm. How was it? Are you still preparing? You're still doing the prep for the Grammys, right? When you add the optical flow, repair frame, or tween node to a comp, the inspector includes a method drop-down menu where you can choose advanced to enable GPU. The Oscars. I'm actually just more surprised by how you can survive on 1 hour of sleep, man. Wow. How do you do it? Do you drink tons of coffee? Then straight to camera tech managing a launch event for Rivian. Rivian. The car company? Rivian. I feel like Rivian... Was Rivian the... Oh, yeah. Cool. Rivian car... They have their Rivian car in Unreal Engine, right? Didn't I see that? Wasn't that what that tech demo was? Yeah, this... I remember the Rivian from the Unreal Engine tech demo about the substrate materials. Across town again for the Oscars rehearsals. Where's it being held? Oscars. Where is the Oscars? Oh, in Hollywood. With the Academy, that's right. So by choosing classic, you get the CPU. And then when you do optical flow advanced, it turns into GPU. That's good to know. At Dolby Theater, I went to Hollywood last year for the first time. Actually, yeah, for the first time. We did the touristy Star Walk. Oh, actually, I was driving back from New York City today, and I saw Conan O'Brien. I did like a fanboy thing. I was like, because I couldn't like stop the car and pull over, but I like drove past him, and me and my wife like were like doing the touristy, like pointed at him. Yeah. But yeah, that was exciting. It was just like it looked like he was talking to somebody else, and like, but at the crosswalk, and he just like looked our way, and that was it. That was it, and we were all like, "Yeah, we saw Conan O'Brien." He looked tall, actually. That was one thing. He had a stoic look on his face. He looked like a majestic warrior. I don't know. By choosing classic from the method you do CPU, from doing advanced, it changes into GPU. And stereoscopic workflows. So the question, BD, is stereoscopic workflows. This is basically for making 3D films or VR, two eyes, right? Like knowing how to change the camera for each eyes and like sync them properly. We're kind of skimming through this stuff though. We want to go in depth on how to like make the resolution of HullCat the highest as possible and just skim through the stuff about 3D stereoscopic workflows. It's priorities, you know? No, I mean, it's hard to do these examples, I guess, right now, but worth kind of skimming over for the concepts. Yes. Awesome. All right. Stereoscopic workflows. There's disparity is the difference between the left and right. Oh, and you can kind of see it in here. It will pop down in the channels as disparity. And it's used by nodes to align and massage the stereo pair of images. This analyzes a stereo pair of images and generates an XY disparity map. The workflow to load a left and right stereo image pair and process those in the disparity node. Once the disparity map is generated, other nodes can process the images. So it's just like optical flow. Same deal. You have to kind of like compute this stuff, and then you can do the stuff. So first comes stereo capture. So disparity map. And then you can kind of do the processing afterwards. When connecting stereo pairs in the node tree, make sure that the left and right images are connected to the left and right inputs of the disparity node. It's probably important to keep those straight. Okay, let's see. No, we could still, I think we could do this thing. Disparity. No. Separate. Swap. No. Separate. No. No. I think there's another node that we can use to make this a stereo. But I think for disparity, you need first the footage, or the two pieces of footage that you're combining, or if it's already converted. We're in theory land right now for me. Make sure that the left and right images are connected to the left and right inputs of the disparity node. Disparity generation, like optical flow, is computationally expensive, so the general idea is that you can pre-generate these channels overnight or on a render farm and save them into an EXR sequence. The tool set is designed around this philosophy. So there's the stereo camera. There are two ways to set up a stereoscopic camera. The common way is to simply add a camera 3. Oh, you can do it in 3D. Add a camera 3D and adjust the eye separation and convergence distance parameters. The other way is to connect another camera to the right stereo camera input port of the camera 3D when viewing the scene through the original camera or rendering, and connecting the camera for creating the right eye content. Renderer, and then another camera, and then we're over here. Let's move this back first, or actually no, let's keep this at the 0 and move our cat. And for both of these, we can set the what is it? We're looking for targets. Set the target as the cat. Yo, what? Where's pivot? Huh? Oh, really? You connect the two cameras together in one node? Does it need to be green? Oh, yeah, you're right. Nice. Nice. Oh, that makes it easier too. Okay. So much for not going into, not experimenting with this. We're going in. And then the idea is what? To offset this? Or we just have it now, right? So the right eye, we would... Oh, nice. I see. So these are connected. They're kind of... That's cool. That was a good thing. Thanks. Thanks for the heads up. And so this represents like the two eyes. Or that's a way to think about it. But so what? So we kind of set that up, but now what? Stereo camera. Do we need to run a disparity map out of here? Stereo camera. There are two ways to set up a stereoscopic camera. We just set it up with... Oh, that's the way that we just set it up. You did it to add disparity, right? Yes, I want to demonstrate this. We have to set disparity here, right? Disparity. So the common way is to simply add a camera 3D and then adjust the eye separation and convergence distance parameters. The other way is to connect another camera to the right. That's the way we did this. And then input port, that's what we did, to camera 3D. When viewing the scene through the original camera or rendering, the connected camera is used for creating the right eye content. There's something we're supposed to do to preview that, though. Let's keep going. In controls, stereoscopic cameras can be done with a single camera or two connected cameras. We should probably try both. We're doing two cameras. Stereo materials, using the stereo mix material node. Stereo mix material. Different textures per eyes. Let's see. Stereo mix. Would it be at the end of it? Stereo mix. What if we disconnect this? Okay, so now it's one camera, and we're able to go into the stereo here. Eye separation. Then, but how do we preview this? I just want to preview it. Camera 3D. No, 3D options. Said in the manual, you have to connect the cameras to the right and left eye inputs of the disparity node. Oh. Huh? Okay. Not sure how it works though. Yeah, let's recenter with the manual here. There's the stereo materials. I'm lost. Yeah. It's all good. It's okay. Don't panic. We got this. There's the stereo materials. Using the stereo mix material node, it is possible to assign different textures per eye. Disparity. Not panicking. Don't panic. The disparity node does the heavy lifting of generating disparity maps. This generates the disparity channel and stores it in the hidden aux channels of their output image. New eye, stereo align. New eye and stereo align use and destroy the disparity channel to do interpolation on the color channel. The hidden channels are destroyed in the process because after the nodes have been applied, the original disparity channels would be invalid. For these nodes to work, there must be either an upstream disparity node. Okay, I think this is... There must be... Well, that's for new eye or stereo line. There must either be a upstream disparity node generating the hidden channels or an OpenEXR loader bringing these channels in. Okay, it goes into it shows the stuff. It shows the goods. Disparity to Z, Z to disparity. These nodes pass through. Hey, welcome back. Welcome back. We're going through learning about stuff. High quality slow motion of cat. We're learning stereoscopic, and we're learning, right now we're trying to figure out how to set up virtual cameras so that we can create stuff that works with like a VR or for 3D viewing. I think actually that's the same process. Same yeah, this is some cool stuff. But we haven't quite gotten it to work yet. But we're getting there. So disparity to Z, Z to disparity. These nodes pass through, modify, or generate new aux channels, but do not destroy any. Tip: if the colors between shots are different, use color corrector or color curves to do a global alignment first before calculating the disparity map. Feed the image you will change into the orange input and the reference into the green input. In the histogram section of the color corrector, select match and also select snapshot match time in the color curves reference section. I feel like this is a real pro tip, but I don't actually understand almost any of that, but I feel like it's important. Hopefully it makes sense for you. Separate versus stack. Stereo nodes can work in separate or stack modes. When in stack mode, the left/right eye are stacked horizontally or vertically, forming one image with double width or height, respectively. The advantage to using stack mode is that you do not have to have duplicate branches of the node editor for the left and right. As a consequence, you will see stereo nodes with 2 inputs and 2 outputs labeled as left and right. When in stack mode, the stack should be connected to the left eye input and the left output should be used for connecting further nodes. Left eye and left output. When in stack mode, the stack should be connected to the left eye input and the left output should be used for connecting further nodes. In stack mode, the respective right eye inputs and outputs are hidden. So setting up stereo in the node editor. Okay, I do need that 5-minute break, right? This is like a cliffhanger. We'll set it up after this commercial break. But I'll leave this up if you want to check it out. We back. We are back. Setting up stereo in the node editor. The disparity generation is the first operation. This can be configured in the node editor in two different ways. In the above example, the workflow on the right, the workflow on the right takes the left and right eye. Is on the left? Or no? What? The workflow on the right takes the left and right eye, generates the disparity. Yo! Welcome back. Hope you had a nice 5-minute break. Generates the disparity. And then new eye is used to generate a new eye for the image right away. The example on the left renders the frames with disparity to intermediate EXR images here. These images are then loaded back into the stereo nodes in a combiner and used to create a new eye images. Okay. All right, let's see if we can set this up. I think there's more though. I see some math, but I don't know if that's math, but close. Close. By using render nodes to compute the disparity first, the later process of the creative operations can be much faster, an interactive experience. That sounds way better, right? So using the render nodes. Although not shown in the above diagram, it is usually a good idea to color correct the right eye to be similar to the left eye before disparity generation, as this helps with the disparity tracking algorithm. The color matching does not need to be perfect. For example, it can be accomplished using the match option in the color corrector's histogram options. Okay. I don't know why they would be different. I'm guessing actually they're talking about actually bringing in two different shots that were filmed and one camera was slightly different color. About the disparity channel. The disparity channel stores the displacement vectors that match pixels in one eye to the other. The left image's disparity channel will contain vectors that map left to right, and the right image's disparity will contain vectors that map right to left. For example, this x left, y left, plus the change in left, I think, the delta left, the change in left. Okay. This delta right, I think it is that. And then it goes to x right, y right times x right, y right, plus the change in right, y, I don't know. Disparity left Oh, disparity left. I think you're right. Yeah. Disparity left. Okay, anyways, math. It's a math. That's how it's done. You would expect for non-occluded pixels that d left equal negative d right, although due to the disparity generation algorithm, this is only an approximate quality. All right, we don't. No, we don't. I know. Okay. I don't mean to. We don't actually need to be reading this hardcore stuff. Oh, but let's skim it. Disparity stores both x and y values before rarely. Disparity stores both x and y values because rarely are left and right images perfectly registered in y, even when taken through a carefully set up camera rig. Both disparity and optical flow values are stored as unnormalized pixel shifts. In particular, note that this breaks from Fusion's resolution-independent convention. After much consideration, this convention was chosen so that the user wouldn't have to worry about rescaling the disparity/flow values when cropping an image or working out scale factors when importing/exporting these channels to other applications. Because the flow and disparity channels store things in pixel shifts, this can cause problems with proxy and autoproxy. Fusion follows that convention, the convention that for proxied images, these channels store unscaled pixel shifts valid for the full-sized images. What is it? Fusion follows the convention that for proxied images, these channels store unscaled pixel shifts valid for the full-sized image. So if you wish to access the disparity values in a script or via a probe, you need to remember to always scale them by the image width height. All right, by that. So I interpret this as like when you get deep into this stuff, when something breaks, you should recall this section and review it. When it doesn't make sense, when you're like, why would they do it that way? That's why. Viewing of disparity. That's what I want to know. How can we see these things? How can we set this up? I still don't actually know. Let's go up here. There's two ways to do this, right? This looks like there's more steps. How do we export the loaders? Or how do we export the cameras? Or it seems like we have to export the cameras, right? If we want to preview this? Still not sure about that. This might be like a right-click thing. Stereo? Stereo. 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 Oh, because it's not connected to anything? Take this off. Wait, we're not getting anything right now. We go here, we go stereo, right eye? No. Why aren't we seeing anything at the moment? Dude. Show me something. What happened to Hellcat? We lost a Hellcat. Uh-oh. Here comes the struggle. Viewing of stereo and optical flow best practices. How you create your composition, the images you are using, and the type of shot you are working on can all have an impact on the success of the disparity generation and optical flow analysis. Below, we'll look at some of the situations to be aware of and how you can avoid some pitfalls when dealing with optical flow. There's semi-transparent objects. The optical flow and disparity generation algorithms By the way, Michael, have you been trying to set this up in the background on the side? Have you figured out how to do this? I'm stumped. The same thing is happening. Now we have no visuals as well. (3D) guide, scale, transparency, views, 2D. Man, this happened yesterday, didn't it? What did I do? I had to restart? Oh, that is weird. That is weird. That's a bug for me. Okay, but we've got visuals. Let's go to stereo and see difference. Not seeing anything. Let's go through these. Checkerboard, nothing. Stereo interlaced. Stereo interlaced. Let's see, if we go to camera and we hop into our camera. Right now we're in the camera, right? So if we go right, okay, let's hop out of the camera and go into perspective. We've got, for some reason, there's three cameras here. Okay, we're definitely like, how do we preview this thing? Film back, no. Because we can see the cameras are on their own. They're doing their own thing. We could go mono. Then we've got these two cameras. There's two ways to set this up. Trying to get the visuals for just one, right? This. Wait. Wait. I think I'm doing something. Something's happening. Renderer. Okay. I'm gonna disconnect this now. Oh, so off axis. So it's like this is the camera that's straight on, and so off axis is like pushing the second camera out. If we have it centered. But the preview is weird. Or that's the preview. And we need to do disparity because it's too far? Or what? I'm looking at this preview of like what happens when I do this convergence. eye separation. I think this is kind of working. Oh, is it because the focus point is so far away? If we move this, we figure out how to get this point to the cat. Would that do it? No, focal plane. What's that dot? I don't actually know what the... I'm not sure what the final image is meant to look like. I just thought... I think there is supposed to be two images of the cat, except that we want... probably just want them a little closer, I thought. And we'd be able to view it as... I don't know, with cool things. Stereo. Stereo. And this doesn't seem to be doing anything. Okay, well, at the beginning of today's episode, I was saying we weren't going to go too deep into this stuff because we don't really have proper examples. But I do think it's possible to export this stuff. It's like you can preview it, and then you can make... You basically would be converting this into a 3D... into footage that would work in 3D. It would get that 3D effect. That's what I'm in search of. Is the 3D effect enabled? Okay, so it's happening. So we had to press enabled. We had to check the enable thing. And now we're getting... That is actually what I was looking for. Funny how neither of us saw the enabled button there. We had to click the turn on button. This... Right? And then we... That's it. This is it. That's... Okay, that's it. Right? I don't know. What format does this export as? That's a good question. I don't know. But that's it. That's the whole concept, right? Is like you separate the cameras and then you basically make it so that they recombine. And it's set up now so that whatever format we exported at, whatever that is, it's gonna look in focus. Yes. Yeah, how do we export this? Taking the aux channel. Where do we export? I don't know, but we got this working. And this is with one camera. I'm gonna Google that. I don't know. I'm curious. Good question. How or what do I export a stereoscopic video to? So, oh, it's called S3D. And it looks like this is supported on YouTube, which is interesting. That's very, very interesting. and you export it as an S3D, creating the illusion of depth when viewed on a VR headset. Or whatever the movies use with those sunglasses, you know. But like it's the same place that we're doing this, same idea. What is stereoscopic? How do I export? How do I export? $3DS. So it's like a special format that I've never heard of. I want to see what Apple does. So to export an entire movie, spatial 3D video export and code. You can encode a left-right stereoscopic video into MV HEVC. That's the regular, or that's the newer. I don't know my codecs, but that's the newer. MP4 can export as that, right? No. What's HEVC? HEVC Cineon? No. EXR QuickTime. QuickTime. Not AV. I guess you will have to buy those codecs, you think? There might be some special codec. Yeah, maybe. Also very possible that we're just kind of missing it right now. You really have to buy any codecs? Maybe. Maybe. So best practices for semi-transparent objects. Oh, there's one other thing. I wanted to just see us get this connected. Wanted to connect this, merge 3D. Okay, so stack. I think going this way is a little more involved. Disparity. Oh, advanced, right? Yeah. Wait, where were we just messing with the disparity here? It was in here, in this single camera. We were able to mess with it on the camera 3D, but then when we plug this in to the right camera, we lose the ability to mess with it here. So, I don't know. Whatever. We got it to work. We got it to work with 1, and 2 is probably when you have actual footage that was maybe literally shot with 2 different cameras. That's when you'd want to understand that workflow. But the way that I'm kind of playing around, and I could imagine myself using this in like making content be accessible for 3D, this is probably the workflow, at least at this stage. We're just doing, it's almost like a, I don't know, it seems easier. There's another step here for 2 cameras. Oh God. Don't die on me, stream. Stream is fine? Okay, cool. Semi-transparent objects. I think we're gonna get through this section today. We're gonna get there. Semi-transparent objects. The optical flow and disparity generation algorithms. Fusion uses assume there is only 1 layer per pixel when tracking pixels from frame to frame. Didn't we read this? In particular, transparent objects and motion blur will cause problems. For example, a shot flying through the clouds with the semi-transparent clouds in the foreground and a distant landscape background will confuse the optical flow stereo algorithms, as they do not recognize overlapping objects with different motions. That's kind of similar with the tracking, isn't it? Similar with the 3D camera tracking. Usually the optical flow will end up tracking regions of one object or the other. If the transparent object and the background are near the same depth and consequently have the same disparity, then it's not a problem. So that's similar with the 3D camera tracker. Motion blur. Motion blur is also a serious problem for the reason explained in the previous point. Same with the 3D camera tracker. The disparity and optical flow algorithms are unsure whether to assign a pixel in the motion blur to the moving object or the background pixel. Because the algorithms used are global in nature, not only the vectors on the motion blur will be wrong, but it will confuse the algorithm on regions close to the motion blur. Yep. Depth of field. Depth of field is also another problem. Similar. Okay, so that's similar with 3D camera tracker. For calculating optical flow, which again, optical flow is... Oh, that's interesting. Oh, because we're previewing... Wait, how are we previewing the left and right? There's no cameras on this. Oh. Disable. Look at that smooth cat. Looks so good. Can we do a sharpen? Is there sharpen? How good can we get this? Sharpen. Why are there 4 different sharpens? Oh yeah, this is the right one. Smooth this cat. Oh my god, it's beautiful. I don't know these settings, but let's see. Let's just add a bunch of sharpens. Sharpen edges. Oh, this is gonna look so good. Cat is gonna look adorable. That's too sharp. Too sharp. Not sharp. gonna really sharpen these up. Let's see how it looks. Oh yeah. Oh, this is looking good. How about one more sharpen? Just the regular sharpen. What's this one look like? Oh yeah, now it looks... Oh, now it looks haunted. Oh, now it's cursed. We should keep going. We should keep going. Keep going in this direction. We want more. Sharpen. Now it's crunchy. Okay, let's tone it back. Let's tone it back. Are there like AI? Are there AI filters in Davinci Resolve? What am I supposed to do? I forget how to get it so that it doesn't process when the blend. Apply mask. What's the thing for this? It's haunted. Alright. Glow. Oh, wow. Just a subtle effects really puts this effect. Really makes... That is really looking just majestic. Where to calculate disparity in optical flow. Where you choose to generate optical flow or disparity in your composition can drastically affect the results. For example, if you have composited a lens flare in, it is better to compute optical flow disparity before that. Yeah. Since the semi-transparent lens flare will confuse the tracking algorithms. If you color correct the left-right eyes to match, or for deflickering, oh, let's try deflickering. Deflicker, because I think there is some deflickering we've got here going on. Detail to restore, all of it. We want all of the detail. Oh my god, it looks way better. I've seen this done before, where if you just add like 6 deflickers, it will look good. I still see some flickering. We want 0. No deflicker. Or we could magnify it. Okay. It is actually making the backgrounds a little better, I think. Here, let's go here. And we can compare it with this. Wait, compare it to this. Definitely looking better. So let's see. If you're color correcting, yeah, so put the optical flow and the disparity stuff, those calculations, before you do the other things. That's pretty straightforward. Cropping the source. This is another concept. As a general tip, if you are cropping down your input images for any reason, it is probably better to compute the optical flow or disparity before the crop, and then afterward crop the flow disparity along with the color. The reason is that flow disparity matching works well when there is common pixel data to match in both frames. But when there are pixels that show up in just one frame, or one eye, then the disparity optical flow nodes must make a guess and fill in the data. The biggest occlusions going from left to right are usually pixels along the left-right edges of the images that get moved outside. This is similar for optical flow when you have a moving camera. Another thing to be aware of are black borders around the edges of your frame, which you should crop away. Yeah, that's what we should do. Is we should future episodes. I need to like rip some footage to play around with. But they're recommending you crop away the border, the black borders, to let this stuff compute. I wonder if the text is actually, it probably is. I bet this text is slightly messing with the optical flow. It's the same thing as like the black border, I believe. Yeah. I think. Picking from the, nodes with multiple outputs. Many of the stereo nodes in the Fusion toolset have multiple outputs. This can cause some confusion to new users. No, we're not new anymore, so we don't get confused. No more. One particularly confusing thing is that when you drag a stereo node to the view, it will always display the left output. Oh, that's what. There's no way to view the right output without connecting another node like brightness contrast to the right output and viewing that. Okay. Picking from auxiliary channels. Some nodes, like stereo line, I don't know. Again, I think this is, is that why I was confused? I mean, maybe that's actually the answer. Maybe that's why we weren't able to view this. And I was like, wait, how do we preview it? No, I don't know. I don't know what that means. We connect this to the right. Or how do we, I don't know. That was my question, was how did we just, now that we have the two cameras, which they look to be working, right? They're enabled. No, that's not working. Or they are. Wait, what? No, I don't know. Are they? I don't know if this is stereo right now. I have two cameras. Maybe they are. Maybe this is. But how do I tell? I can't do disparity changes because they're both kind of locked on, maybe? No. Huh? Oh. Okay. I don't know. Again, okay, we're sticking with just doing it this way for now, for today. Picking from aux channels, some nodes, like stereo line, allow one to drag pick from the Z or disparity auxiliary channels. You must pick from a node upstream of the stereo line, not from the output of the stereo line. If you try to pick a disparity from the output of the stereo line node, you will get nothing because stereo line consumes and then destroys the disparity auxiliary channel. And even if you did not destroy the disparity channel, you would still be picking the wrong value since you would be picking from the aligned result. Moving along here, we're just going to keep moving. Let's keep moving. That stuff will all make sense after you sleep. Once you go take a rest, that'll all make sense perfectly. The typical workflow for picking is view stereo line in the left view, view the node upstream of the stereo line in the right view, and then pick the disparity value from the left eye in the right view. All right, once again, we're just introducing these concepts, reading about them, and skimming it. Although this picking functionality does not operate any differently from normal picking of color channels, this issue may cause some confusion. Like us, we're confused. If it helps, the analogous workflow mistake with color nodes would be a user trying to... So the example workflow mistake with color nodes would be a user trying to pick a gradient color for a background node from a view showing the background node itself. You are trying to pick a color from a node from its own output. Yeah. Okay. And then another issue that you need to be aware of is which eye you are picking. To avoid problems, it's a good idea to always pick from the left eye. The reason is that the disparity channels from the left and right eyes are different, and when you pick from a horizontal/vertical stereo stack, Fusion has no way of knowing whether you picked the disparity value from the left or right eye. The above are not hard and fast rules. Rather, they are guidelines to prevent shootings. No shooting yourself in the foot. If you understood the above reasoning fully, which we do, just not at the moment, but eventually, you'll realize there are exceptions, like picking disparity from the left out of the disparity to Z and the Z. All right, whatever. Moving along. Vector and disparity channels. The vector and back vector channels store the forward and reverse optical flow. So the optical flow is also computed. And the vector channel might be better named forward vector or forward flow, since the name vector to describe a channel is not technically correct, as the more mathematically inclined user might recognize that all the channels except for the scalar channels... Alright, alright, whatever. This stuff exists. Disparity, optical flow. Actually, I do want to know optical flow. But so optical flow is kind of a part of... It's a part in the computation of stereo computations. And disparity and optical flow values are stored as unnormalized pixel shifts. These channels store unscaled pixel shifts. When using vector and back vector auxiliary channels, remember that all nodes expect these aux channels to be filled with the flow between sequential frames. More precisely, if you have a sequence of 3 frames, ABC, then B vector will contain the flow from B to C. Yeah, so this is, again, talking about optical flow. It's kind of how it works. That they calculate between each other. They flow between each other. When working with these channels, it is the user's responsibility to follow these rules, or for clever users to abandon them. That's us. We're abandoning everything here. No. Nodes like Time Stretcher will not function correctly since they still expect the channels to contain flow. Yes. Time Stretcher. I feel like putting this here is a little redundant because earlier, just to remind how it works, it's like media in, you do an optical flow, and then you can do your effect, your optical flow effect. So this is our optical flow effect. It makes it so that the frame blending looks nice. This is no frame blending. And this is with like the non-optical flow, but it's still it's like doing some sort of thing to blend between. And then with our optical flow here, and messing with this stuff makes it so that this looks good. You can adjust the optical flow settings here. I did watch somebody who was saying that like it's best to set the warp count usually for real amounts of footage. You want to do something like maybe 7 iterations, same deal, is you can experiment with like what you think looks good. By default, this is 10, and then this thing usually goes up to 100. You can just type in like 400 to boost that up. But again, it's kind of processor heavy, like hard on your computer. Do high quality iteration counts. If it's higher, it's just doing more. So currently, the DOD, the definition of the region of interest, and what was it? Something of definition. Region of interest is not supported for all Fusion nodes. And that's it. Domain of definition. We're done. Ah, that was tough. That was a tough one, but we did it. Yeah. We did it. We did it. That last part, that was this stuff was all, that was, I mean, maybe need to revisit. But we are done. We're done with that. Done with the fundamentals. And now it's like a Pokemon, like do 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 da 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 da. We're evolving. Now we're VFX artist. I said VF fart. So we got Fusion fundamentals are complete. We're complete. How long did that take? That was 28 days times 3 hours. That was 84 hours. 83 hours, because technically we've still got an hour. 83 hours to get through the fundamentals. And now we get to apply the fundamentals. That's what we're going to do in the next. I'm going to take the 5-minute break a little early. No. I'm going to think about like what to do next. How to apply these. Our superpowers. We got to test our superpowers. See what's the slam, the gamma slammer. Yeah. Yeah. Yeah, gamma slammer. The gamma slammer. Yes. That is amazing. Amazing. The gamma slammer. What's next? What is next? I gotta look into things. I gotta think about that. Or we start, I think for today, it's probably best we just like play around. And then that maybe is like the thing that we should be doing for a little while. Is just like messing around and trying to make cool things. Yeah. Making memes. Yeah, what next? What next? Actually, wait, we did mention that the other day, didn't we? Like the idea, I like that idea that like moving forward, it's just we pick one of these, we take a peek, we play with it for like 15 minutes of the stream so that we are kind of chipping away at this, but it's like it's a chip, you know? We just chip away at this stuff for a while and it's like 3D nodes, and that's kind of the thing to get started into the stream, you know, as a way to like learn something new for sure, and then kind of start things off for the day and then see where we go from there. I also had the idea of like what we could do is yeah, let's talk about it. I think it's best to like right now just hi Amici on YouTube. I think right now it's best to just play around, just mess around with this stuff. Start this. But I had this idea that it'd be sweet if we started like working on a project. But that might take more pre I don't know. I don't know. Working on something that like creating something that we can chip away at every day, make like a shot for, and then put it together. I think for a project, I don't know. I think it is early to say it. I'm saying like a project as like the thing to keep in mind, but like to get started, we don't need to figure out what the project is yet. We want to just start playing around with different looks, starting with like messing with the 3D nodes and then jumping into like trying to make something in the 3D nodes, or it's like, hey, today's few pages on 3D nodes, here they are. Now let's go make something completely different, unrelated with 3D nodes. I could see that happening. But yeah, I think next up we got to start making some cool stuff that will get more people into the stream. Recording some footage off stream, I'll probably do that and bringing it on. Messing with whatever's the popular meme at the time, doing a spin on popular memes. That's probably that would be a good use if we can get the footage, like whatever's popular on Instagram, taking that and then putting a spin on it, whatever that means, whatever that turns into. But taking this to market, you know, that's what I mean. Going big, going for the next steps, going for that 5 minute break. We're big time, yeah. No, not yet. We have to like apply this stuff now. Imagine. Yeah, we gotta apply this stuff. But 5 minute break. I'll be right back. Now it all begins. BRB. We're back. We're back. Gamma Slammer. Gamma Slammer Mike. Let's see. Oh my god. This is called Next Level. It's a new release, and we're allowed to play it on stream. Very fitting. Yeah, we made it. Level 2. We just keep adding clothes. That's how to get to the next level. Damn. Damn, it goes hard. Okay, what are we gonna do? Okay. Alright. So, how can we, what are we gonna do? No more honk hat. Now we need to make new fusion comps and make some cool things happen. We basically have infinite power now, because we know everything, because we read the manual. So how do we apply this? Let's see. There's a few options here. Maybe we should write some ideas. We got memes. We could do movies. Memes or memes and movies. Memes and movies. So that'd be like maybe like taking the. I saw one the other day. Here's an example. This is something that we could actually do now. This one. I can't play the audio because, you know, it's kind of hard to see, right? But the guy, he painted out Elmo, or he painted out the main character and replaced him with Elmo. That's an idea. So Elmo and Dune, that's like a, what's involved in that? That was, he's making clean mats. So he's painting out paint outs. tracking, and what else is involved in that? There's tracking, and there's color matching. I watch a guy on YouTube who puts movie characters inside games. It's crazy how good he makes them look. What's you wanna post it? You can post the link in the Twitch chat. So there's tracking shots, there's color correction for that stuff, but what is the broader style of that or technique? That's replacement, right? Character replace, character paint outs, character replace, replacements, statements, which are paint outs, tracking, and color corrections. And I also saw some properly set up. There's 3D camera track, or he used motion blur. He matched the motion blur. Yeah. So that is like a pillar, right? A pillar of VFX is replacements, like getting a person into a thing, getting things into the world of a person. I was excited with the 3D camera tracker. 3D camera tracker. I was excited when we were playing around with that. So that's tracking a space and then putting things into that world. I was just excited with that, having fun. Basic tracking, but 3D camera tracking, for me, that's all about putting compositing things into a world, into the world or the footage, making it a 3D space to put things in. Oh, cool. Cool. I've never seen this before. Is there music? There's music. Is this actually, wait, is this, this guy looks very much like, Sacha Baron Cohen. It's not, right? No. This is a compositing. It is him? Wait, how is this? Wait, what am I watching? What is this? Or is he compositing footage of Sacha Baron Cohen? Or did he get him to like do this acting for him? You know? Is that footage from his movie? Oh wow. All right. I actually thought it was green screen, but he cuts him out as well. Nice. Yeah, this is good stuff. This is good to... I don't think that's Magic Mask. I think it's hand. That's hand tracking. I think he's hand tracking him out, I think. Actually, yeah, it looks like it, right? Doesn't it look like you can see sort of the straighter edges here? So he probably goes through and like hand cuts out everything. Rotoscope. Or he probably, or it could be a combination of like Magic Mask with, or you know what? It's probably every single shot. He's probably like, do I need to hand cut it, or should I do Magic Mask? Oh, I like that idea. But so that's rotoscoping, and that's combining characters to add into scenes, into scenes. So he's cutting that out, and he's also finding the right angles. Do you know if were those cutscenes or was this just gameplay footage? This is cutscenes, right? Damn. Combination of both. Man. Yeah. I'm impressed. I mean, like, technically, I'd like to try some of this stuff so we could technically play with it. There's another part to this, which is like, I don't know how he's, I mean, he has to go through, I don't know how he's getting it, how he's matching these, the angles and everything. If it's like, if he's just going through and watching this movie and being like, oh, I could probably connect that with that scene when he's in this angle, you know? He matches the colors so well. Yeah, for sure. That's a cool idea. Okay. All right, so that's rotoscoping. We definitely got to be doing, we got to do rotoscope work at least a few times. That's rotoscoping. All right. But so if we have footage, Instagram, like what's are there any websites to see like what's trending on Instagram? Is that a thing? Are there websites to like look into what's trending? Slaying social, is that? Oh, this looks cool. Trying to find, because we're like, I don't know. I was thinking, like, why not try and compete in a way? Like, trying to see what's trending, and then we do our spin on it. Yeah, and we make it better. Or like finding like in a way kind of what I was doing where it's like like upsampling memes or like editing memes, combining memes. See, like that looks good. One cat never looked so good. Yeah, look at that. It's beautiful. Isn't there like a beauty? There is a beauty. Yeah, here's the beauty. Oh, whoops. Huh? Make it more beautiful. Oh. The gamma. We gotta slam the gam. Slam the gamma. There we go. I don't see any difference here. Oh, no, it's way better. Way better. Let's turn off the deflickers. Delete the deflickers. I think it's going to be a combination of all these things. We just kind of try and pick and choose and see where it heads to get started. Play around. Catch a line, you know? Throw out some ideas. Maybe we'll catch one that like we'll be like, oh yeah, let's explore that a little further. Then we yeet ourselves into the memes. Maybe put on some music. Let's see. What? One second. One moment. Just a moment. All right, so go here, input this to let's get some footage in here. Hmm? Huh? Oh. I'm trying to bring in some footage. Um. Hmm? Let's see, new project. It's not importing. Oh, because that's probably the thing. I'm trying to bring in a trailer. Oh, it says an MP3. Oh, come on. There we go. Okay. So no audio. But we got this. So in, out, and then we can what is it? If we set the in and out, then we can just grab the footage there, because we don't want any audio. So we have our footage here. So what could we do? we could stabilize the camera. Well, actually, yeah, no, wait, that's the first thing that we probably would want to do. We want to add a tracker. A camera tracker or a single tracker. If we do just a regular tracker, because this shot is interesting, it's like there's camera jitter. See it? And it kind of comes up. So if we were gonna put anything into this scene, we'd have to first kind of staple that down. We do have some black bars as well. Remember they were recommending cropping that. Go there, and then we go, no. There, then Y offset. Okay, good enough. I guess. Does that make sense? Whatever. Okay, let's try tracker. And we track something in the far distance. And we're trying to go for those little jitters. So this thing. And if we stabilize the jitters, we can add something back in. There's no camera movement. So we set it to best match. Let it go. That is it. Oh, because let's reset that. I'm just annoyed with those. Reset. Where's delete? Now if we apply this to like a text 3D, or if we get an object, what object would we want in this world? Let's put a text. Text for now. We're gonna send this through a render. Oh, we gotta set up a camera, then set up a render, and apply the tracker. We set the tracker to operation match move, right? And we plug this in. And what am I doing wrong? We don't necessarily have to set this up on a image plane, right? Layout, characters. Wait. Pass through lights, renderer 3D. Okay. Okay. Okay, wait. Something's happening. We're doing something. There's a few things that just came to mind. Is that we have to crop this guy out. We have to crop him out. We have to, this is one way. I'm gonna make a magic mask of him and save that out, and then bring it back in to do a mask. So I'm gonna just try magic mask on him, which we didn't even read about, but whatever. You know what a magic mask is. It's masking on easy mode. Okay. Perfect. Get that. Get out of here. Get out of here with that. Okay. And we're at the end here, so we'll just track backwards. Perfect. Perfect. Good enough. Good enough. And I think we're... Ooh, that was actually a pretty good one. Matte. Erode. We want to erode it. Yeah. Tiny bit. Gamma. Slam it. Oh, no. Blur. Yeah. And then, that's pretty good, man. Maybe we don't need to go restore fringe, and then we restore the fringe, right? All right, that's good enough. That's pretty good. And then I'm gonna do what I said, which was save this out, because that's like the pro way to do that. Get more familiar with this workflow, because that's the pro way. And we're trying to be pro, man. We're trying to be pro. So we go here, renders. I'm gonna save it to a new folder called savers. And do. And then we go fusion, render, we go. And then we can turn this stuff off. Turn it off. Bring in a loader. Bada bing, bada boom. Now we're saving space on the render. On the composite. We put this guy onto the merge, right? Yes, yes, right, right, yes, right, okay. Yeah. Oh, and it's messed up. We bring this back. We should have taken a look before we did that. All right. Anyways, we're okay. Because then we can just mess with this magic mask. Blur. No. No. We need to bring the erode. Yeah. There we go. There we go. That's it. Actually, we're done. That's that's it. That's the whole setup. We did it. we're we're making some cool things all of a sudden. We could do the thing that we learned the other day with the instance. Try to make some cool text. Extrude it. Disconnect the extrude type. Actually, here, let's, for disconnecting, let's just make the depth like there. The instance text, we're gonna disconnect the instance, and the shading, the instance. Let's try and yoink this color, and we can go to text. What was it? Bevel depth, and oh, because it's not previewing, gotta plug it in. Oh boy, too much. Like that. And the this text should be, I don't know. There. Then if we flip the text down, or we have it fly in, zoom in, skirt, or make it look like it's the thing that just made the stuff blow up. Or it just hovers up. I don't know. I don't know what to do with it. Here. Which one? X, Y. Let's do the Y. Oh, we never figured out how to make it properly do a shadow. I think I know. I've got an idea. If we do another instance here, look, I think this might be it. If we just do another instance and we do the shading, the black, I think this is it. This is cool. It's kind of, it's fake shadow, but whatever. If we de-instance the rotation. Oh, we gotta plug it in, right? Put it here. Yep, yep. We're also gonna de-instance this. No, this is, no, it gets tricky. If I wanted to animate the text in, this isn't gonna work, right? If I wanted to like, but what we could do is blur this. Wait, is there text? No, there's no like text blur, right? We can add the blur. We plug that in? Let me plug it in. Huh? Do I have to go like this? Oh, it's a text 3D, so it needs to be like a 3D blur, right? 3D blur? Blur 3D? Blur. Depth blur. Nah. No, there's no like 3D blur, is there? Nah. This might not work the way that I was hoping. There's like a dirty way to do it. No. Okay. Okay. So if we're gonna work in 3D space, we're gonna figure out how to get the shadow properly working. I thought the way to do it was you had to set up a plane, and then you had to have a light, and it was casting the shadow onto the plane, and the plane is set to be a shadow catcher. I thought that was like the whole process. That sounds right, yeah. Visibility, shadow, receiver. This is a shadow receiver. Plug it in. And form, rotate it. No. Let's do 90 degrees. I don't think that matters. Okay, and then we do the scale. We can scale it up. Oh, maybe the scale last time was screwing with things. Let's see. We add a light in here. Let's set it to, it is spotlight. We can set the target of the light. Can I do? Okay, that spot. And then we can just like throw the light into position. Move it over here. Huh? Huh? Okay. Okay, whatever. We're just throwing, it doesn't matter too much, I think. Okay. Whatever. Okay, that's in position for it to at least give off a shadow. So we'll set it to, first let's look at shadows. Enable shadows. Plug it in. Text 3D with the renderer 3D. We got to go to the render, lighting, shadows. Lighting. What the? Damn it. And where's our plane? How come that thing's not showing up? Plane. Front. What? Front and back. Huh? Huh? Like, how come we're not seeing the thing? Is matte opaque? No. Oh, no. Blend mode, no. Huh. This is such a strange issue. Two-sided, specular, exponent. Oh, because there's no color for it. We didn't actually, there's not, right? Yeah, but, what the huh? Is the camera, no, the camera, oh. Oops. Okay, so I'm thinking now, like, we didn't set up, no. No. Okay, but that looks pretty good. But the thing is that we didn't set up, we didn't set up the, okay, let's bring it real close. Did we need that? Effects, shadow receiver. Oh man. This is killing me. Default camera. Renderer, merge 3D, pass through? No. How to make a shadow receiver in Davinci Resolve.
Renderer, we want to make sure that we're not in OpenGL. We want to make sure we're in software renderer.
Okay.
Then we want to go into our tracking mesh. And inside our tracking mesh, we got to set up a few things. We need to go down to our lighting and click on shadow receiver. And then we're going to go into our material. And what we want to do is bring this to pure white. Because the operation we're going to use is we're going to turn this entire image to white except for the shadow. And then in this merge, we'll multiply our image against our original footage, so it'll just be the shadow. Then after we change it to all white, we want to come down to where it says receives, and we want to click off lighting, but then click on shadows. And now you can start to see the shadows. But we still have a couple problems here. We still have this part. If we look at our actual camera renderer, we have this part here isn't white, and we also have our text.
Oh wait. What did that just make me think? That it's camera? No. What? That I want to make sure that something is set just the way that he showed. But which thing? The renderer 3D. Oh. Oh, that looks kind of weird. Okay. Okay. We're at least making progress in this shadow thing. But The image plane, we want to make sure that it's not affected by light. No. No, that it's not a caster. No. That's interesting. Look, because when we say shadow receiver, like I want only the shadow, right? But that's weird. When I click off shadow receiver, only that turns off. I want like all this stuff removed. Do I may?
Text. So let's take care of the first problem with the background. Let's grab a background node and let's make that pure white. Make sure these are all 1 and add that into our camera. Okay, now we're getting a full white screen, but now we still need to get rid of the 3D text. So if we go over to our 3D text and we go over to the shading tab, there's an option in shading elements where it says opacity. And if we turn that down, you can see that we've gotten rid of the text, but the text is still inside the 3D scene and can cast a shadow. So now if we go over to our merge and we change our apply mode to multiply, now you can see that we actually have a true shadow catcher here inside Fusion. Now one thing I did want to mention is that inside of 3D text, we do have this shading elements where you have the opacity. A lot of times you're going to be working with different kinds of objects like FBXs and alembics, and the way that they come in is going to be a little bit different place for this opacity. So let's bring in a 3D shape, and I just want to show you where to find that option. So everything else in this scene can stay the same. And let's make a cube. Put this up in the scene. And
Yeah, I want the text. I want the text. Oh, I want the cube.
Let's just bring this over so you can see it. So if you have, when you have a FBX or an OBJ or a lembic scene that comes in, you can just go into the materials, and if you look in the diffuse, you'll see you have the opacity option here, and you can just turn it down, and you get the same kind of results. I just want to show that to you because it's a little bit different than the 3D text.
Oh, that is actually different. That's for us, isn't it? No. Is it?
You can just go into the materials, and if you look in the diffuse, you'll see you have the opacity option here, and you can just turn it down, and you get the same kind of result.
Wait, so the way to get rid of the background, the image plane, how do I get rid of the image plane? Is it a matte? Opaque? No, no, no. Blend mode? No. 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 So you need to make 2 3D scenes, one for the text and one for the shadow. Oh. That sounds good. That sounds big brain. Yeah, that sounds okay. So I need to make 2 3D scenes, one for the text and one for the shadow. I have somewhat of an idea, but I don't know how to explain it. Let's look at this a little bit more. Maybe he
that to you because it's a little bit different than
he might explain stuff.
So I'm going to delete that. So now we have our shadow pass, but we want to put together the rest of our composite. So what we can do is let's select these 3 here. So we have our camera, our 3D merge, and our camera render. And let's copy that. And then we'll go down here and paste it. And this renderer is where we're going to have just the 3D text. So we're going to merge this over the top of that merge. And let's look through the final composite. So the spotlight can go straight into the 3D scene. The spotlight will be the same in both. But the 3D text is a little bit different because of this 3D text, we brought the opacity down so that we could just have the shadow pass. But what we can do is let's copy the 3D text and then paste an instance. And let's connect that instance into our 3D scene here.
Dude.
Because we want the translation, everything, color, rotation, all of that stuff to be exactly the same in both. But what we can do in this instance is we come over to the shading panel, and under the opacity, if we right click on opacity, we can de-instance just the opacity. So everything else is going to stay the same. These two will be exactly the same, just not the opacity. And we can bring that up. And so now we have our 3D text by itself rendered right here, and then we can merge that over the top for our final composite.
Sheesh.
And now that gives us a lot of room to be able to, after this renderer, do all kinds of things before we merge it in. So we could blur this a little bit more. We could add a little bit of grain to the text. And it gives us a lot more options for our compositing.
Sheesh.
So let's do a quick overview of this process. So we have our media in here.
Mm-hmm.
We have our shadow pass.
Wait. So many steps. But we need the shadow. We need it.
Gives us a lot more options for our compositing. So let's do a quick overview of this process. So we have our media in here. Then we have our shadow pass, which is this section right here. And the way we got this shadow pass is that we added a background. And in this background, we made it pure white. We added that into our 3D camera. So the entire background is white. Then our ground plane, which is our tracking mesh. We went inside the tracking mesh. This is our shadow catcher. And we turned on shadow receiver, so it'll receive shadows. Then we went inside the texture of our shadow catcher, our tracking mesh. We made the diffuse pure white, so all the values are at 1. Then we turned off receive lighting and then turned on shadows to add shadow.
Oh, this is going into the pink one. So you put the white background into the pink thingamajig. I don't know if we're gonna set this up today. We might. This might need a fresh day's approach. Let's finish this.
Make sure that in the camera renderer, that our render type is software renderer. And then the 3D text, we went inside the 3D text and we went to the shading tab. And we just turned down the opacity of the shading so that the final render here, the 3D text won't show up in the render, but it'll still be used for the shadow pass. And then we took that and we merged it using the multiply operation over our original clip. Then down here, we copied the camera, the 3D merge, and the camera renderer from our shadow catcher and added it down here for our 3D text. Then we took our text from our shadow pass and instancing it. But in this instance of the 3D text, what we did is we de-instanced just the opacity and brought that up. So the translation and rotation and everything like that is still linked. Everything is linked between these two, just not the opacity. And we added that into our scene with the spotlight from our shadow scene so that everything matches up. And then we rendered that out and then brought it over the top for our final composite. So that's.
Oh yeah, duh. Why didn't I just think of that? Why didn't I think of that? But it does make sense. But there's no way I was gonna. There's some things I just have to have explained to you, huh? I was not gonna logic myself into figuring this one out.
And we just turned down the opacity of the shading so that the final render
wasn't gonna reason my way. But we gotta. It's 10.
Here,
we do have to do this. We have to do this. We have to like identify the stuff that we don't know how to do them. We gotta build Yeah, we gotta basically just apply this stuff now, right? Apply the different nodes and make different things. We gotta do it. We gotta do it. Yeah. All right. Sweet. So that's. I'm gonna get more footage. I'm gonna start taking footage. I'll sleep on it. We'll see. We'll see. We'll just see. We'll just see what happens. See where this goes. Dune. It's going places. Dune. Dune. Yeah. Yeah. Gotta take a break. Gotta take a chill. I will catch you tomorrow, where we take the first step of the new level that we've just ascended to. We start to, now we have no excuse, and we have to start making stuff that looks cool or hilarious or hilariously cool. I'll catch you next time. Thanks for hanging out, Gamma Slamma. Thanks for, see ya. See you next time. Peace. Oh. So, hey, Alfredo. I'm just seeing your messages. If you're still there, I'm usually watching the Twitch. Oh man, I missed your chat. I'm usually watching Twitch chat. So you said if you wanted to make a shadow on the ground, you need to add a 3D plane on the ground, add a spotlight above, and then use it against the real plate, using brightness contrast to detail the shadow. Your plane is not showing up as it is parallel to the camera. Oh, you need to change the angle. Instance. Yeah, so we're gonna try that tomorrow. So I didn't see your messages. Sorry about that, Alfredo. But thanks for tuning in. We're gonna pick this up tomorrow. For sure, I'll see your messages on Twitch. Also, I'll probably see them if I'm fresh. I just missed them on the side. Sorry.